here. So good morning again, everyone. Thanks for coming in on this final Zoom class day. First thing I want to look at real quick before we get into our IXL is I want to show you, and I think I've shown this to you before, but so this is what I look at when I'm looking for IXL scores. So I've just kind of chosen a section so you can see some scores here. So you'll notice this is second period that I'm looking at, 8th grade score grid, all students for second period, 8th grade. So I can scroll through and see all the different IXL sections. So this is, what section is this? This is Z, so functions, when we started doing functions and we're working with those. So you'll notice up here, you see a lot of green there where people were working. So specifically, right, like this section, Trevor was the only one that worked on it. So it shows me that he's got that score, and I can hover over it, tell me how many questions he did, how long it took him. And if I wanted to get more detail about the questions, I can click on that and it'll open a new window for me and show me all of the questions, whether right or wrong, what he answered, all of that. Okay, so I have a lot of detail that I can look at. So when I am asking you to take a snapshot or picture of the IXL section, if it doesn't show up here, right, that snapshot or picture will not work as your grade. Okay, so please don't send me a picture of something and be like, yep, I'm done. Well, if it doesn't show up here, right, like if Andrew sent me this, I don't think Andrew's going to do that, but if Andrew sent me a picture and said, hey, I finished Z16, and I look and Andrew doesn't have a score under Z16, well, then I'm not going to be able to count that score until it shows up there. Okay, so please make sure as you're doing your IXL and submitting your work that it actually is going to show up for me. That means you got to be signed in, you got to do the section and all of that. All right. So let's go to the section that we're going to work on today. And we'll do a couple of practice problems from there, similar to the worksheet. The other thing about the worksheet, I've had some people submit the worksheet to me already, and I was looking at them. Please make sure that when you're submitting a worksheet that I can actually read what's on the picture, all right? At least one that I got was just very blurry and I could not read what was written there. So please make sure before you submit your picture for the worksheet that you are, that it's a clear picture that I can actually read pretty easily, all right? Make sure that your name's on it and all of that, so I can see that it's your paper as well. All right, so what we're doing today, again, is AA8, so we're solving systems using substitution. So we'll do a few practice problems from here. And most of these will start out somewhat the same as what we were looking at for that worksheet. So you'll see where one of the equations already tells you a portion of the solution. So this first equation here says y equals 10, okay? Well, y equals 10, that means that the y value is going to be 10, all right? What I need to then figure out is the x value, okay? So with this problem, let me copy it over to my whiteboard real quick, and then we will do that problem. So let me just write it on my whiteboard. I'll share that screen with you. All right, the one thing I want to point out on this is all that we looked at on our notes and the practice from Monday was things in slope-intercept form. Well, this is not in slope-intercept form, the second equation. That second equation is in standard form. So we want to talk about how to use that as well. All right, so let me switch over to the whiteboard here. All right, so in standard form, when we have something in standard form, we want to put it into slope-intercept, all right, so that we can solve for x first, all right? But in this case, this situation is where we already have y equals a value. So we could do one of two things. I'm going to show you the way that I would like you to do all of these problems, though, and skip the second option for now, all right, just so to avoid any confusion. So this problem, first thing we want to do if it's in standard form is get it into slope-intercept. In other words, get y by itself. So for this problem, the first thing we want to do when we're changing standard form to slope-intercept is always move this x term to the other side where it becomes its opposite. So in this case, I'm technically going to add 6x to both sides. All right, by doing this, I get y by itself because there is no coefficient on y. So I'm going to say y equals, these two things don't combine. So I'm going to list the x first and then minus 8, okay? Now, for this problem, it's this equation is now in slope-intercept form, all right? So I want to use this equation for, I want to basically replace this whole thing with what I just changed it to, all right? So I'm going to ignore that for now and use these two equations. So I'm going to use y equals 10 and y equals 6x minus 8, all right? So let me just erase the one down here so I have a little bit of room to work. So those are the two equations I want to use. Now, when using substitution for this, y is equal to 10. So I'm going to replace y in the other equation that has the x expression so I can figure out what x is and solve for that. So I'm going to replace y with 10. So that becomes 10 instead of y. And I'm going to keep this expression over here. And then I'm just going to solve this for x. So this is a two-step equation technically, right? So first thing I want to do in this two-step equation is get this x term by itself by getting rid of this one. So I want to get this off of that side. So I'm going to say plus 8 and plus 8. All right, so that's going to equal 18 on this side and leave me with a 6x over here. All right, second step to the two-step equation is to get x by itself. So the first step was to get the x term by itself. Now is to get just the x by itself. So this is 6 times x. To reverse that multiplication, I'm going to divide, okay? So opposite operation there. And this is going to say x equals 3 on this. So the solution that I want is going to say, right, the solution again is always that coordinate value of where those lines would cross. So we already put in the 10 on IXL for the y. Now we know that x is 3. All right, so a little bit of work on that to get it into slope-intercept first, and then solve the equation from there. All right, so let's switch back over to IXL and put in that answer. All right, so that x is going to equal 3. All right. All right, now this one, again, we've got a standard form equation. We've got now x equals negative 10. Well, again, it's telling us something on here that we already know a portion of our solution then. So this portion of the solution we know this time is the x. So I can go ahead and put in x is negative 10 because it's telling me that. All right, that equation just a number equal to a variable tells me a portion of my solution. So let me rewrite the rest of this over onto the whiteboard and we'll solve the remainder. And again, we've got a standard form equation here with negative x minus y equals 16 and the x is equal to negative 10. All right, so first thing we want to do if we've got that standard form is put it into slope-intercept. So let's do that first. All right, and this is why we learned that in the last unit at the end here, so we could use it in this unit for solutions. So first thing I want to do is move this x to the other side, right? I want to get y by itself. And I don't want negative y, but I just want y. All right, so I'm going to put technically ones in front of these, right? Negative 1x and negative 1y. So I'm going to move this x to the other side by adding 1x or adding x. All right, when I add x to this side, I can't actually combine it with the 16, right? Because they're not like terms. So what I'm left with over here is negative 1y equal to, in this case, I'll just list the x first because we want y equals mx plus b. So the x term is going to come first. And that's going to be then plus 16. That 16 was positive, so it would be a plus. All right, last step then is to get y by itself. I don't want this negative 1, I want it to be a positive 1. So what I'm going to do is divide to get rid of that negative 1. All right, that's a two-step process to get rid of these, and this is a 1x again, to get rid of this term to the other side and the coefficient on the y. So as we divide this, negative 1 divided by 1 is just 1 or 1y. So just y is what we'll say. 1 divided by negative 1 is a negative 1x. And then a positive 16 divided by a negative 1 is a negative 16. All right, so that would be our slope-intercept form for this. Now, on to what we want to actually do here, which is substitute to figure out the other portion of our solution. So y is the other portion of our solution because we already know x. So I'm going to substitute this negative 10 in place of x in this equation to figure out what y is. All right, so as I do that, I'll get y equals negative 1 times x. So if x is going to be negative 10, I'll replace that x with the negative 10 and then minus 16. All right, so just simplifying this to figure out what y is now, I'm going to do the multiplication before I do the subtraction. So negative 1 times negative 10 is 10 minus 16. 10 minus 16 is a negative 6, so y equals negative 6. So my solution is going to be x is negative 10, y is negative 6. Okay, any questions on that process? All right, some of this is going to, as I said, go back to what we did in the previous unit of changing standard form to slope-intercept and then using our slope-intercept. So let's go ahead and get that in over here on IXL. So negative 10, negative 6. Right. All right, so again, similar type of problem here, right? We want to change this standard form to slope-intercept and then figure out our y value. So we'll skip that because it's a similar problem. Just going to jump ahead so that we can get to problems like this, which is, and notice the SMART score in this one has jumped up to over 80 already. So hopefully the simpler versions of these things will appear prior to 80. But this is our two standard or two slope-intercept equations, okay, where it's not telling us a value of any particular number, right? It's not telling us x or y directly in this problem. It's giving us two slope-intercept equations, and we'll need to solve for both variables. So again, let me write our two equations onto our whiteboard here, and then I'll switch over. So we got y equals 10x plus 10, and y equals 6x plus 2. So in substitution, when we have two slope-intercept equations, right, all we're going to do, step one, is going to be to set the two x expressions equal to each other. So I'm going to forget about the y for a little bit, and I'll come back to it in my final step of this. So first step is to take this x expression and set it equal to this x expression. So I'm going to create a whole new equation that says 10x plus 10 equals 6x plus 2. Right, now this is a multi-step equation where we got variables on both sides, constants on both sides, so we'll need to do some movement of those And what I said in our notes is the first step after this, the second step technically, is to get all of our x terms over to the left side. So I want to get rid of this one on the right. So I'm going to subtract 6x there to get that x term off of the right side and move it over here. So I'll do that as well. My new equation at that point says 4x plus 10 equals, what's left over here is just the 2. All right. Next step is to get all of these constants over to the right. So I don't want this one on the left, so I'm going to subtract this 10 from both sides and simplify. So 4x equals 2 minus 10 is -8. All right. Last step in finding x is going to be to divide my coefficient. Figure out what x is by getting rid of this times 4. So if I don't want times 4, I'm going to divide by 4, both sides. So x is equal to -2. All right, so that's a portion of my solution. So my solution is going to be a coordinate point of -2 something. I've got to figure out that something. I can come back then. My final step is now to come back to either of these two equations, okay? One is not necessarily going to be easier than the other here, all right, because I have multiplication in both, right? I'd have to multiply the x by 10 in this one, the x by 6 in this one, and add. So they have the same operations. I don't know that one is necessarily easier than the other, but I'll choose this one with the smaller numbers just in general. So I'll use this one as the equation. I will replace x value to figure out my y. So in this say, I'm going to say y equals 6, and instead of times x, I'm going to use -2 that I just found as my x value to figure out what y is. So the +2 remains there. So first thing is 6 times -2 is -12. Add the 2. All right, and -12 plus 2 is -10. So my y value is -10 on that. Okay. So any questions on that substitution where we have to find both solutions, both x and y? All right, so -2, -10 was our solution there. All right. So what we're going to do, unless we have some questions prior to that, is we're going to go ahead and split into our groups. So let's see here. Before we do that, let's just check in with Miss Carrie, see if she thinks we need to cover anything else. Miss Carrie, you
looks good to me.
think we got that covered? All right.
Yep.
So we will go into groups here. The screen share off real quick. All right, so let's see here. 2 rooms. And I will give you, let's see, 1, 2, 3, 4, 5, it looks like 6 actually. All right, so 6 in your room and the rest I will take.
Okay.
All right. All right, we'll see you guys in the rooms then.
Mr. Peters,
Yes.
what do we do if the y has a number attached to it? Like,
Can you show me what you're talking about?
yeah.
All right, so I'm going to show you the second way to do this as well, just because sometimes it's easier here. So let me just copy that down for a second. Get this off of the screen, and then I will copy that down and show you what I'm talking about. I'll show you the way that I just taught you, but I want to show you the secondary way in case you find it an easier method, perhaps.
Okay.
So let's see, that's negative 7x, or is that just 7x?
Negative.
Okay. All right, so let me share my screen. All right, so with this, right, if we were doing it the way that I just showed you, we would move this x to the other side, because first thing we want to do is get this out of standard form. So we would move the x term to the other side by adding 7x, right? So if we add 7x and add 7x, then we get negative 6y equals 7x plus 13, right? And then we would divide by negative 6. That coefficient on the y is what I think you were talking about.
Yeah.
So we would divide that, and then this gives you y equals negative 7/6 plus, or sorry, minus 13/6. Well, that's a weird fractional answer that I don't know that I would want to deal with, right? So here's the other way to do this, and probably the easier way for this particular problem is if you're given standard form and a number is the other one. So it just says y equals 6, for example, right? So I'm going to get rid of all of this stuff that I just did and show you the other way. But if you use that way, then you would just plug in the 6 and figure out what that was, and it would come out as a fraction, and it probably will still come out as a fraction. I just think that this way is going to be the easier way to deal with it.
Okay.
When you have that, if you just take the 6 for the y and replace y in the standard form. Okay, so just leave it in the standard form first, and then just replace y. So if you come over here and now you replace y with 6, now you can just solve for the x from there. So this is going to be the equation that you would have. Okay.
Okay.
First simplify this, right? Do that multiplication problem. So you would get negative 7x, and then this becomes 36, so minus 36 equals 13. And now this is just a two-step equation to solve. So you would add 36 to get the x term by itself. All right, and that is negative 7x still on this side. And over here is now 49. All right, and then divide by the negative 7 to get the x by itself. Now you've got a much easier problem than something that had a bunch of fractions. Okay, so when you leave it in standard form and evaluate it from there, sometimes the equation is easier to solve if you're given a problem like this.
And then the y would just be 6 because.
Yeah.
Okay. Thank you.
Yep. All right, so this equation that you have, or these two equations that you have, are both in slope-intercept form, or sorry, standard form. What you want them in is slope-intercept form, okay? So this one is fairly simple to change because you got y by itself already, okay? So you just need to do is move the x to the other side by adding 2x, right? Get rid of that negative 2x to get y by itself. So this equation changes to slope-intercept fairly simply with just one step. Right, so that's the first one. This one isn't going to change quite as easily because of this -7. All right, so
All right.
I'm going to show you one more thing here that I haven't shown you yet, and that is we can, when we use substitution, it's great to have both of them in slope-intercept form, but if I change this thing to slope-intercept form, right, I'll just show you what it looks like by doing it. I'm going to subtract x from both sides, right? So I would subtract x, and I get -7y equals -x minus 5. I would divide everything by -7, right? And I'm going to wind up with a bunch of fractions on that right side because I'm going to get -1 divided by -7 is 1/7 x, and then I'm going to get -5 divided by -7 is positive 5/7. So I get two fractions. I don't like fractions in my equations, honestly, like, because the first thing we have, and we've talked about this earlier in the year, that we would multiply by 7 to get rid of all of the x's or the fractions, and we can do that. But if we can avoid having the fractions in the first place, that's what I would like to do, okay? So I'm going to just go back and erase all of this work for a moment and show you one more thing that substitution can allow you to do. And that is, even though we don't know what y is as a number, we do know what it is as an expression. We know y is equal to 2x minus 16 in this other equation, right? You following me?
Yeah.
Okay. So if we know what y is equal to, whether it's a number or just an expression, we can replace y, as I've been talking with Cassidy about, just leaving this one in standard form and replacing whatever we know is the other. Like, so if we know the number of x or we know the number of y, we can just leave it in standard form and replace it to figure out the other one. Same thing works here. If I know y is equal to 2x minus 16, I can simply replace y with 2x minus 16 in this other equation, right? So this equation tells me what y is equal to, so in the standard form, I can replace it. So in other words, I'm going to leave everything else except that y is going to change to this expression. So I'm going to have x minus 7, but instead of y, I'm going to use that 2x minus 16. Whoops. Okay. And then the equals -5 will remain. All right. Do you see what I did there?
Yeah, I see.
So we're just taking that, whatever y equals here, it equals 2x minus 16. So I'm just going to replace it. Now, this is going to require me to do a little bit of distribution and things like that, but it's not going to give me any fractions here, okay, which is what I'm avoiding, okay? So if I distribute this -7, right, to these two terms, all right, so I get x there. This becomes -7 times 2x gives me -14x. All right, and then -7 times -16, right? Remember that sign goes with it. Gives me a positive, let's see, 7, that's 40, 7, so
112.
equals -5. All right, so still am avoiding the fractions that would have occurred had I changed this to slope-intercept form. All right, so now I just got to do a little bit more work to simplify this side because I've got some like terms now. Right? So I've got x and minus 14x. Well, 1x minus 14 is going to give me a -13x plus the 112 equals -5. Right? And now I've got a two-step equation. So I'm going to subtract the 112. So I get -13x equals -112. Or sorry, that's not correct. Let me fix that. -117. right? Because -5 and -112 give me the -117. And let's see, do you have a calculator on you?
Yeah.
Can you do that division problem for me here?
All right. I got 9.
Okay, that's what I thought it was, but it wasn't positive. So negative divided by a negative gives me a +9 there. So that's my x. All right. So a lot of work to get there, but I avoided the fractions if I changed both. Okay. Now what
All right.
I can do now is go back to this one where y is equal to something and replace x. Okay. So I'm going to get my y value by replacing this x with 9. So I'm going to say y equals 2. Instead of x, I'm going to use 9 and then minus 16. So do my multiplication first. So that's 18 minus 16. So y is equal to 2. All right. So 9 for x, 2 for y. Right.
Okay, I see. I see
So
now.
again, not a simple problem necessarily, but there are some steps you can do to avoid the fraction issue.
Yeah, I probably would go with that.
So that's how you can do those. So sorry you got the stinker of a problem there so early, but in all the times that I went through this section, I never got 2 standard form equations before 70. So sorry about that, but there you go.
All right. Thank you so much.
You're welcome. All right, guys, as we begin to close out these breakout rooms, all right, remember you can come see us in office hours if you need any additional help. So office hours from 2 to 3 today, 2 to 3. Actually, tomorrow, I think our office hours, we have a meeting set up at that time. So I'm not sure our office hours on Thursday are actually going to be open. But if you need help, just let me know. I can open up office hours a little earlier tomorrow since I don't actually have class. But just send me a message and I can probably do it from like 1 to 2 or something like that if you need it. All right. So last class, congratulations on reaching the end. Hopefully we will see everyone at some point in the next week or so. And it has been a pleasure teaching you guys. Sorry that this is the way that it ended, but I think we've had a great year in math, and you guys are all going to be very successful moving forward, all right? Congrats. We will see you all sometime around the bend. Fist bump out.